So, good afternoon, everyone. Hope you have a nice day here at Bit Summit. The coffee is great, the food is great, the people are great. So, hope everyone's having fun. Today, I want to talk about how we can unlock AWS Serverless using Terraform. So, how we're going to do this is I'm going to explain a little bit about Serverless is, like giving some concepts, some examples. We're going to talk about what Terraform is also, do some examples, show some code. Then we'll do some summarizing of both technologies. And if we have time, we can have one of my two examples. We have one that's cool one that we will have build a serverless API application that also triggers email notification. And if we don't have time, I will do also another one, which is just a simple API that's going to get data. But both are interesting and show the concept right away. For those who don't know me, my name is Lopes. I'm currently a senior software engineer working at Tesla. I'm a AWS community builder, which is an amazing program started by AWS that helps support content creators and people that try to make the AWS community better by sharing knowledge across the world. Would recommend anyone that is interested in AWS and also sharing knowledge to check the program later. I'm currently a AWS Solution Architect certified. I need to actually renew this year. They sent me an email, so I'm going to have to study again, but it's OK. This year, I finally took my Terraform associate certification. Took me like 3 years to actually want to do this. I don't know why, but we postpone things. For those who want to connect, you can see here on the left side the QR code for my LinkedIn. The code for the demos are also going to be presented on my GitHub page under unlocking AWS Serverless with Terraform. I also run a personal blog for now at Medium, because I think it's easier to distribute stuff there. And my email if anyone wants to keep in contact. So let's get started. So what is serverless, right? So anyone here knows or used serverless before? Oh, a lot of people. Yeah. As long as nobody is now building the whole application, the whole infrastructure architecture using serverless, everything will be OK. I remember when serverless went out and everyone wanted to no, we need to move everything to serverless. Like, yeah, just look at your bill by the end of the month. OK? So serverless is the concept of outsourcing the base and management of your infrastructure to your cloud provider. So it's not that you're not going to have servers anymore, but you're not caring how it's managed or how it's provisioned per se. You just want to use it. So you don't have a direct infrastructure. You don't go like, OK, give me this server. So in AWS, you would say, give me this EC2. So you actually don't care. You just want to deploy code and want to be ready to use it. I like to call this a service as a service because you're going to be interacting with service for your cloud provider. So for example, in an AWS, everything that you just go to the console and say, I want to use this, and they give you like a address or its name, and then you just send a request to that, that's considered serverless because you're not going to care about the memory usage, you're not going to care about space, anything. So API gateway, DynamoDB, Fargate, AWS Lambdas, which is the first example that everyone comes in mind, SQS, even S3, and EFS, they are considered serverless. Serverless is scalable and also highly available, because in theory, what you have is the whole region of that serverless service is going to be your actually infrastructure. So as long as the service is available in that region and you want to use it, that means that you're going to have, theoretically, all the infrastructure available for that service. So for example, here, for example, here, you have just like a small representation of requests coming and being processed by a server. So someone from the internet sends a request, the server processes it, keeps busy processing it, and then completes and is free to process more requests. The problem is when you need to scale this, right? So your server has reached all the available processing capacity for that time, and then it needs to process more things. So what are you going to do in AWS? You have an AOB, or sorry, a scale group that's going to say, OK, I need more infrastructure for this. And then what they're going to do, they're going to provision a new server for you. And the server is going to be up, and it's going to be ready to process. But there's a problem. The problem is that usually you have a cooldown period to identify if more infrastructure is actually needed or not, because it can be something that is just out of nowhere, and then it's just over. So usually the default one is 5 minutes, depending on the servers that you're using. And then aside from that, you also have the boot time from your server. So when you boot the server again, so you need to install everything, you need to be ready, you need to start your application again. And this takes time. And at the same time, you're losing requests because of that. Aside from serverless, for example, here we have an API gateway and a Lambda. A Lambda can process 1,000 concurrent requests. Concurrent requests, I would say concurrent requests at the same time, but concurrent is at the same time. So, and it's actually really fast, because requests come, you just say like, yeah, I need more, so just do it, just do it, just do it, just do it. This actually can become a trap, depending on how we structure our application, but we'll talk about that later. Theoretically, you have zero idle capacity, and that means that you will not have wasted resources, because all the resources that you are using are only, quote unquote, alive during the processing request. So you only pay for what you use on a serverless model, right? And theoretically, everything is disposed after being used. So here I have an example of a simple message, a simple request. So it goes to API Gateway, Lambda, and then processes in DynamoDB, and then it sends a request. So you can see like it processes it, and it's alive only during the request. After that, you don't care anymore, because you're not paying for that anymore. And it can be cost efficient. I say can be, because as I mentioned before, you have traps in serverless. And it was very visible on the earlier days of serverless, where people would just like use it without any, not knowledge, but with some ingenuity of that serverless solves everything. But for example, if you leave an API gateway open with like no authorization, no authentication, and it's connected directly to a Lambda function, and for some reason, someone maliciously finds out that. And they say, OK, that's interesting. Let's attack this. Let's send a DDoS attack on this. And serverless don't know when to stop, right? And so it's going to just come up, and you see your bill on the end of the month. And it's pretty sad. I've seen this happening in production. It's not very nice. And then we come to the other point, that it requires a comprehensive design. Because you cannot just say like, oh, I'm going just to convert my API to serverless. Why not? It's easy, right? You just get an API gateway and use a Lambda. Just one Lambda, right, to do everything. It's not that, because you need to think on how you're going to optimize your code so your service is not going to be over-processing things, because you want to keep it processing as minimal as possible. For example, here we have like an example of a classic architecture. We have the internet, server, database, and we have also an email server, right? One of the many approaches that you could get is this one. You have an API gateway connected to a Lambda to get the data, to a Lambda to create data, a Lambda, and they both are connected to a DynamoDB. One Lambda then dispatches a message to SNS, which sends this message to a SQS queue that is then processed by a Lambda function for email processing that uses SES to dispatch emails. I say this is one of the many because you have like the flexibility of changing or adapting this by all means. For example, instead of using SNS and SQS, we could just use a DynamoDB string, connect directly to the email notification Lambda. That would be another way of doing this. But the important thing is that keeping things as minimal as possible, and the Lambdas, they should at least just have one responsibility, because it's easier for you to debug, it's easier for you to maintain, and you're not going to have too much bootstrap code. So your code starts going to be smaller, and your processing time is also going to be faster. So moving to the other interesting part, we have Terraform, right? So Terraform is one of the many tools for infrastructure as code, which in theory they say infrastructure as code, but you're not actually coding your infrastructure. You're coding a blueprint of what you want the state of your infrastructure to be. So, for example, here we have a Lambda function code. So you give the file name, you give the function name that you want, you give a role, you give the handler name, the runtime, and environment variables. Here is just a representation of using Node.js. But depending on the runtime that you're using, it's a little bit different. This is a simpler one for an SNS topic. So you just have 3 lines of code. I mean, this is a simplistic way of saying that. Of course, you need to give permissions to the services that this SNS topic needs to have access to. But if you want to just see on the console, that's what you need to do. This also will give you code reusability, because now you don't need to click around on the console anymore, right? So what you're going to do is going to code your infrastructure. So if you need 50 SNS topics, you just, if you're, for example, copy-paste 50 times. You don't need to click around 50 times in the console, which makes your life a lot easier. One of the most used reusability terms in Terraform we have is variables. So on the left side, the left side, yes, you have locals, which are variables that have the scope of your local configuration. So you can only use inside that file, for example. Yeah, on the configuration, sorry, not the file, on the configuration. Because if you have modules, then this variable is not scoped there. So inside your configuration, you have locals. So for example, here I want to have the same tags, common tags for all the services that I have in the Terraform configuration. So I just declare a local, and then I just have to reuse this variable. Aside from if you need to do that manually, you need to go in each service, and you need to give tags to each service. On the right side, we also have variables, which are variables that have information coming from outside your configuration. So for example, if you have to give security or secret to Terraform, like secret keys, then you declare a variable, and you get from the configuration outside during the run. For example, when you need to Terraform plan or Terraform deploy, you do this. And it's the same concept. You just declare the variables, and then you reuse it everywhere. We have a more interesting concept here, which is called Terraform modules. It's where you bundle together code that you want to reuse across your configuration. Or if you have it available you can make it available for other services or repositories to use. That's actually an interesting thing to do. So here is an actual code for Lambda function. So you see I have resource, data, and data. And if I want to create a module with this, I just transform this in this. And so instead of repeating this code here everywhere, I just need to do this. It's much easier. So also Terraform now, because how it works, you're not going to click around anymore. You're just going to write it, and you deploy it using what is called a Terraform runner. A Terraform runner is just a fancy name for a server that's going to run the Terraform deploy code for you. So because we're removing the human factor of deploying it in repetitive work, so we are going to have reduced provisioning errors. And at the same time, we have also consistency between environments, because if I want to deploy this in another account or another region, as long as the region can support the same services that we are trying to create, then everything is going to be working fine. For example, we have an account A and an engineer. And this engineer is tasked to provision some infrastructure in this account. So he goes one time, provisions an API gateway, a Lambda function, a DynamoDB, and gives some role and policies to this Lambda function, so this Lambda function can access DynamoDB. But the same engineer now has to do the same thing, but in account B or in another region. But for some reason, he forgets to give policies to this Lambda function, which will cause this function to lose access to DynamoDB. And we all know that these things are only found out when you go to production, right? And you say, your clients are say, wait, why is my application not working? Yeah, you forgot something there. And The worst part is trying to debug this is just a nightmare. At the same time, if you're using like Terraform, the only thing that you need to do is code your Terraform code, give it to an ISC runner, and the ISC runner is going to be tasked to do the same infrastructure for you in both accounts. As long, as I said, as long as both accounts are in the regions that support the same service, everything's going to be just fine. Theoretically, Terraform is cloud agnostic. It's because you only learn the HCP language once, and then you have the concepts to do everything like locals, modules, variables, string manipulation. It's all one thing that you need to learn. Of course, the resources, they are different between cloud providers, but the language itself, you just learn it once. Gives you access to organization and documentation of your infrastructure. And we all know that in AWS, things can get a little bit confusing from time to time, and gets worse when you go multi-region or multi-account, because it's a little bit harder to find what your infrastructure has and what have you provisioned. But this year is going to be, everything is going to be in one place, in a Git repository for you. And if you want to find something, you just do like Control F, and then you'll find it. For example, one of the many ways of structuring your Terraform code is in our repository for your application. You have like a folder called ISC. Then you have a folder for your modules. You have a folder for your APIs. You have a file for your buckets, a file for your lambdas providers. And everything is in one place. It's much easier for you to understand how your architecture is actually structured. It enforces team and company standards, but it's not in a way that's going to prevent you from doing nice stuff, but it's in a way that if you don't have to look around for loads of documentation to understand what you can and what you can't do on your application. For example, what's the range of the IP range that you can use for an EC2 machine, for example? And what are the policies that I can give to a Lambda function? So it's much easier to enforce standards. For example, we have modules where you can have default standards, default behaviors for some services, or you can also have like WIS or other CI applications that will scan your code and say, yeah, so you see you have this policy here and it's not allowed for a S3 bucket. S3 bucket cannot be public. So as I said, you can enforce behaviors like security policies, security groups, default behaviors, networking, and the list goes on. And one of the nicest things that you have is versioning of your infrastructure. So you deploy something by accident to production and everything breaks. The only thing that you need to do is revert to the previous commit and redeploy your infrastructure, and everything, in theory, will be working just fine. And as a last one, serverless and Terraform, they are both technologies that allows you to focus on development. So you don't need to click around on or try to provision infrastructure, waste time with that. So with Terraform, your infrastructure, you just need to code it. And with serverless, you don't care about how the infrastructure is actually provisioned or managed. And with that, you're going to have like faster deployment and faster provisioning. Because you can also use reuse code, like modules, for example, as I showed before. And now if you want to have like 3 lambdas, you just need to repeat the code 3 times. It's much easier. And you're also going to have like a better architecture review, because chances are if you're using serverless on your applications, you're going to have like hundreds of services. And as I said, it can be like tricky to keep track of everything that you have. And having Terraform to assist serverless on this is much easier for you to understand how your architecture is actually structured. And I think we can have a quick demo. Let's see. So I will try to do this one. This one is cool. Let me just get this one here and put it here. So in this one here, I have 3 lambdas. One for, it's like movie management. It's like a simple thing. So I have one for creating things, like boilerplate code in JavaScript, just for validating the requests and creating data in DynamoDB. I think I can make this bigger, better. And then it published this movie to SNS. We have an email notification lambda, which is basically pulling message from SQS and then dispatching an event to SES. Simple. And one simple for getting data. You can just pass the movie ID and a path parameters, and then it's just get the data from DynamoDB. And I think I don't have anything here. I have thing here, but I don't want this. No. OK, so let's start with getting data, right? So I will copy this folder here. Yeah, definitely. And here. So the only thing that I have is we have the terraform.tf, which is the main entry point for Terraform. It's going to be where you configure your provider. So I have the Terraform keyword here, where say I require this provider for AWS, and at least the version is going to be 5.83. And here I configure a backend, which is where Terraform is going to store the state, right? And a state is just how Terraform knows what is already created and what are the configurations for this resource. If you don't have a backend, Terraform will default to local backend, so in your local machine. But the problem is with CI/CD, you're definitely not going to get the same machine. So if you don't have it, Terraform will assume that you don't have anything created, and we'll try to recreate everything from scratch. And then you're going to start seeing conflicts. So if possible, always try to use a backend. And then here, just provider keyword for AWS. You actually don't need this, because Terraform is smart enough to understand which resource belongs to which provider. But as a way to understand and know the provider that you're using is also always a best practice to have this here. I have some variables just for getting a region and the account ID. This here is just variables.tfr is just boilerplate code, which I need to remove from here, or else I'm not going to be able to deploy it. What else? We have a REST API here, API gateway. So it's going to be called Movies API, and it's going to have a resource of live, deployment of live. So it's going to be like the URL/live. Then I create a resource called movies/movies, and then a resource for movies getting is a movies ID. And here I just create the method. The method comes from a module here, where I bundle all this code here inside that one. And what else? We have lambdas, which is also a module for lambdas. When I give a source where the module is, the name of this lambda function, some policies that I wanted to have, and some environment variables, which is here, it's just the DynamoDB table. And some policies. This one is for get item from DynamoDB. And the Lambda code is just similar to that one that I showed you, but now it's using Node.js 22. And here I just have initializer code, which is because you cannot deploy a Lambda without a code. So even if you go to the console and you say, create a new Lambda for me, it's going to give you a similar code to this one. OK, so the only thing that I need to do is commit it, and then this here, no, destroy, this deploy infrastructure is going to run, which is basically just setting TF-vars, Terraform variables, using environment variables, checking out the code, initializing AWS, setting up Terraform, initializing Terraform, doing some format check to see if the code is well formatted, creating a plan, and then applying this plan. So ideally, we would have what's it called, an approval step between plan and apply, because the plan is going to give you everything that Terraform will try to create or edit or destroy. So you first would ideally check, OK, is this actually what I want to do? And then you would approve it if it is or is not. But here, we don't care. So we just go and apply everything. I could actually just go through Terraform and then Terraform apply, but I like to see the plan. And then we have one for deploying the Lambda here, which is just boilerplate in code for doing npm install, run build, zipping the build, and updating the Lambda code. So let's hope this works. Let's hope this works. Because I did this demo many times, but something always goes wrong. Yeah, I'm on the correct. One time I did this here, I'm like, why is not updating? And then I say, yeah, I'm not logged in. So yeah, this one is going to fail because I don't have this Lambda. This one here is going to fail because the Lambda is not created yet. And this also is going to fail because the Lambda is not there. So, but we can retrigger this one later. So the interesting part is this one. You can see that it generates a plan. So it says like, OK, I'm going to try to create everything. So you can see that this here is reading data, so data sources, and this is going to try to create. If you have like a minus red, is what it's going to try to destroy. If you have a tilde in yellow, it's something that is going to be changed. It's very simple. And the plan is going to output everything that it knows what's going to be created before apply, because there are some things that you actually just know after applying the code, like the URL for an API gateway. You only know that after creating it. So you can see that it was completed, and I have actually see here the API gateway. And if I go to the console here, and I want to see, like, for example, the Lambda, you can see I have this one here. This here was something that I was trying to do, and I failed miserably to do, but it's OK. So, for example, yeah, this one here, just get that one, and then I can save it and send a request. I should get like hello from Lambda, which is the default code that I have there. But now, if I do deploy get Lambda, I just run this workflow. Yeah. Oh yeah, this is from 5 months ago. Wait, no, I'm on the wrong. Just cancel this. For some reason, I left that tab open. I shouldn't have left it open. I knew I would do that. So I'm on the correct place. I can see everything failed, but at least failed as expected. So that's good. Failed successfully. I just need to rerun this job. And this one is faster. So for Lambdas, if you have a code that is under 10 megabytes, you can deploy like this. But if you have a code that is over 10 megabytes, then you need to deploy it through S3. Like if you have like a bunch of external NPM packages and you need to bundle together, then you need to do through S3 or create a Lambda layer. But usually the Lambda runtime already has like a bunch of NPM packages, mostly also the AWS packages, so that helps a lot. OK, so it deployed. So if I do this and yes, and it's OK, I close this one, and I send the request again, and I click it. You can see that now I get data instead of a hello from Lambda, because I deployed the Lambda. Pretty simple. So now, let's go to the other one, which is, no, it's here. Create one. So I just go here. I will just update my IAC for IAM policies. So now I'm going to give a policy for put item. I will create a new Lambda. Yes, I will create a new Lambda. So as you can see, the only thing that I need to do is rewrite the module, write a new module for that. And I will just also add a new endpoint. So if you see here, the only thing that I did on this one here, I linked the new method to my deployment, and I just used a module for creating this new method. So like pretty simple. And the only thing that I need to do is get this here, stage it, and add create. And I can just go here. And while doing that, I will just temporary email, because I will need this. And sometimes it takes a little bit of time to create it. That's why. OK, so see that it's running. So it's initializing the configuration. So initialize basically gets all the modules that we're going to use. We're going to download it, all the modules and providers, and so it can use. Because in the backend of Terraform, it's basically just Go requests that that the Terraform runner is going to be using to call AWS endpoints to create, modify, or delete things. So you can see here, the only thing that it's doing is creating things and updating the API gateway. So it applied it. So now I can just close, 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 close. And instead of calling this one, I can call this one. And I will just get hello from Lambda, because it's deployed with the boilerplate code. Now the only thing that I need to do is go and deploy create movie. So install packages, build, zip it, and then update the Lambda code. Cool, updated it. So now if I send this request here again, you can see that I have this here. And to prove that I actually have data, I can get this ID and use on the get one, and I should get the same response. No, just in out of order, but you understand the point. OK, so for my next trick, I will use this one here. I will add this here. And to secrets and variables. I'm going blind already. Age. So I will just update this one with this one here. Yeah, of course, why not? I use password, yes. Okay, better. Okay, I update that one because for this one, I will need environment variable from email. So I will just come to email notification, and I will just create this email here, which is just creating a resource for SES, sorry, email identity and configuration set. What else? I'm going to update the IAM policies here. So I will give a send email policy to the identities, to someone to do that, receive message to SQS, SNS, and SNS. In messaging, we have created a local variable for a topic. So you have the queue here, and you have the topic, SNS topic here, and SNS queue. And I'm just giving permissions for this SNS topic to dispatch stuff to SQS, send message to SQS. And the variables, I'm just going to update the variables here. So I'm adding the email identity and destination email here. And you can see that it's already here. And I think that's it. Updated variables, updated messaging, and the Lambda. So I'm just adding a new Lambda to have the email identity and destination email here. And I think that's that I need. I need also to update the. Do I need to update the deploy infrastructure? No, I have the email here already. So we are cool. So you can see like I'm passing the email here for email identity and destination email. So if I did everything correctly, then it's fine. If not, we revisit it. So we just stage it. and email. So you're gonna just update the Lambda. Oh, remove the, I forgot this, but it's okay. It's not gonna break anything. This one is for the get movie Lambda. So if I try to call it now, it's gonna not have a table name. But it's okay, we're not gonna use it, I hope. And here is just updating some policies. Oh yeah, I need to fix that. I removed the login policies from the create movie. Okay, so what's happening is I got this email here from AWS requesting to just click on this email to verify the email. So you just click it and it just comes here, and then it says like, your email identity is verified. Yeah, so created everything, and now I can just deploy the email notification Lambda. And yes. So the only thing that I need to do to test it out is going on the create movie again and send another request. So it sent this request here, and if, oh no, I closed it. Yeah, because I need to go back here. Yes. Back to list. And it's loading. I always forget that from this one here, you just, yep. So you can see that I got an email with like just some data that I sent through that. And yeah, that's it. I still need to fix some things on this example, but we didn't need those lambdas anyway. So cool. Thank you. Do you have any questions?